So as we saw in the practical implementation, what is a warm piece of code and what's a hot piece of code. Now let's see what's an optimizing compiler. Optimizing compiler basically works on assumptions. Okay, so say suppose there are two assumptions, A1 and A2. So there are the optimizing compiler works on n number of assumptions. There are two main assumptions that it works on. Okay, so the assumptions made by the optimizing compiler are basically if the objects affecting that piece of code is created by the same constructor. For example, the constructor obj this.x equals to x, this.y equals to y, correct? Each and every object which is being created by this particular constructor will have the same x and y in the same order, correct? So if they are created by the same constructor and are in the same order, okay, there are certain decisions which are made on the data which has been collected by the baseline compiler, right? Okay. So what happens next? Now the problem occurs, right? JS is a dynamically typed language. We understood what is dynamically typed language, correct? So what happens now? As JS is a dynamically typed language, for example, if an array is being summed up, right? Array has 100 elements. All the elements need not to be integers, right? An array can be an amalgamation of integer, string, boolean, anything, correct? So 100 elements can be of string integer type, and 99 elements can be of integer type, and that one element can be of string type. This is where the optimization goes for a toss. Okay, two things can happen. Either this can happen or this cannot happen, right? So if the situation does not arise, it will. So based on this, right? Based on this, the baseline that the optimizing compiler has made some optimizing strategies, correct? This kind of a situation arises. So there can be two. This kind of a situation is there, right? This is a use case. There can be two ways, two things that can happen, which is this kind of situation does not arise. So what happens? It uses this optimization, and the optimization with the optimization, the code becomes faster. It happens. Now what happens, right? Suppose this kind of situation arises. What happens now? The optimizing strategy which the baseline compiler has made till now just goes for a toss. It is a garbage. It is trashed. It has been trashed. Okay. What happens now? So the execution goes back to the baseline compiler. So the last part is the optimizing compiler. It has made all its optimization, but whatever rules it has made, it has gone for a toss because it was summing up all the integers and all of a sudden that string comes in, right? The strategy which it had made is garbage now. It goes for a toss. What happens? So it goes back to the baseline compiler or the interpreter. This is called de-optimization. Now, if we do not write code properly, your application or your code will go for the optimizations, which will increase the operational overhead of your code. Okay, so this can become a common issue in our code. So what happens? Mainly in most of the JS engines, they do this optimization and de-optimization cycle for 10 times, and then they stop doing the optimization cycle. Okay. Now let's see. Let's get into a little more depth. Like how does the optimization thing happen? Okay. So optimization and de-optimization. So let us understand what is type specialization. Okay. So this is this piece of code I was talking about. Like we had seen this piece of code practically. Also we have seen this piece of code, correct? Okay. So what happens? So this is a okay. I have written the spelling of R here is wrong. It's okay, no problem. You understand that this is array, right? Okay, this is the some array which is receiving an array variable, and then it is adding the elements of that array. Okay, now what happens? This is the piece of code which is being redundant. It is being executed again and again and again, correct? It seems to be easy, right? It's a normal easy logic where basically the sum of the array is happening, where say suppose the array is of 110 length and it has got all integer, it sums it up. What happens when a string gets or a boolean gets introduced in that array? Understand this. Even if the array contains string and integers, like even if the array is allowed to contain string and integers, the addition of integers and the concatenation of strings are two very different operations. Okay, so how does the optimizing, how does the compiler, not the optimizing, how is the compiler deals with it, right? So uh, the JIT basically deals with it by sending it to the baseline compiler, where each and every code is stubbed. Each and every line of this code is stubbed. Right? Each and every line. So stub can be a number of lines of a number of representations of a particular piece of code. Right? So this can have 5 lines of representation. Right? So we'll see. We'll see. So stubs can be of two types. One is monomorphic and another is polymorphic. What is a monomorphic stub? So a monomorphic stub is basically a piece of code which is always, a monomorphic stub is a piece of code which is always executed with the same type of variables. Okay, executed with the same type of variables. Okay, so if this piece of code is being executed all the times with integer, then this can be stubbed with monomorphic stubs. Okay, a polymorphic stub is basically something where the type differs. So example, this array has strings, has boolean, right? So this will become a polymorphic stub. So this particular line will have different stubs for different types of data. Integer will have one type of stub, string will have another type of stub, the boolean will have another type of stub, right? Okay, so now what happens? The single line of code can have different stubs depending on the kind of data it's dealing with. As we discussed, JIT asks a lot of questions before using the stub, right? The JIT compiler has to ask a lot of questions, right? Which stub I have to use, like stub 1, stub 2 or stub 3, right? What type of data I'm dealing with, right? So the stub looks something like this. For example, is the sum variable an integer? Is the array variable an array? Is an I integer? Is the I variable an integer? And is the a of I, that is the elements that we are working with, are all integers? Okay, then it goes into this loop, right? It goes into this loop and it asks these questions again and again, right? And these questions, although make the compiler or compilation optimized, but when it is asked again and again, it does increase a little bit of operational overhead. Correct. Now what happens? Okay, so the optimization compiler, when sees that this is a particular question which is being asked again and again, it goes to the the baseline compiler sees these questions are being asked again and again, it goes to the optimization compiler. The optimization compiler basically stubs the whole function. When it sees that function is being hot and it is being used again and again, the whole function is stubbed. So if the whole function is stubbed, we already have information, right? So these informations are clubbed together, and there are few informations which will be asked again and again, right? For example, from these 4 stubs, or 3 stubs can be clubbed together and say one stub, like for example, this needs to be asked again and again, correct? Because we do not know what kind of element we are going to deal with as the functionality proceeds, correct? So it happens something like this. The stubs will be is sum and int, because the sum variable will be an int, right? Is array and int, is array and variable of array, correct? Instance of array, and I is int, correct? Now what happens is this particular question is being asked again and again. Is array of I, a of I is an array. If the element of the array is an integer, should be an integer. This should be an integer. Is a of I an integer, right? So it will ask each and every time it gets inside this array if this particular element of this array an integer or not. Then it will then it will add each and every element of this array. Now if it encounters a boolean, a string, it gets into the de-optimization cycle. Once it gets into the de-optimization cycle, it goes back to this, and then it goes back to the interpreter. Okay, this is how basically the de-optimization and optimization occurs. Okay, now because most of us work on Chrome, let's see how Chrome does it, how the V8 engine does it. Okay,